Okay guys, you now had practice with calculating heat with a temperature change and calculating heat without a temperature change. Now what happens if we start with, say, negative 32 degrees and we go all the way up to 50 degrees? Okay, well, if you think about a phase change graph, you are going through multiple segments of that graph. So what I want you to do is you need to turn to page 9. We're going to go through the first two examples with you, maybe the first one. Okay, so the first one, if you take a look at it, it's asking us to calculate the amount of energy required to take 125 grams of water. So there's my mass. So I'm going to actually write this down right here. My mass is 125 grams. From negative 15 degrees to 45 degrees. Now, here is something that I want you to do for every single one of these. I want you to draw a quick phase change graph. It doesn't have to be anything big, okay? Just a very, very small one. And if you notice in my answer key, I have this phase change graph on every single one of them, okay? So I'm starting at negative 15 degrees. Where on this phase change graph is that? I know this plateau is 0, and this plateau is 100. So I know it's somewhere about right there, okay? That's where I'm starting. But then I'm going up to 45 degrees Celsius. That is somewhere around here. The reason why I want you to draw a phase change graph like that is because you don't just do one problem, Q equals MC delta T. Yes, we have a phase change graph, or a phase change, a temperature change. But within that temperature change, we also have that phase change. So guess what? We actually have to do, look at how many segments it goes through. This is the first segment, so I have to calculate Q for that segment. I have to calculate Q for that segment. I have to calculate Q for that segment. So I have to calculate 3 different Q values. So my first Q, I have a temperature change there, so I can use Q equals MC delta T. So my mass is 125 times specific heat of water, 4.184, times my temperature change. Okay? Now here's the thing you need to remember. I'm from here to here on this segment. So this one is 0 degrees Celsius. So 0 degrees minus, was it negative 15 I started at? Negative 15. Okay, and I calculate that first Q value. So that gets me at 780.45. So my next Q value is my phase change. Phase change, there is not a temperature change. So I need to use my Q equals H times M. So I'm going to go Q, and I'm at that first plateau, so I'm going to use my fusion. 334 times 125. So that is my heat required to go through that particular phase change. But I'm still not done yet, because I still need to go this little bit on this change. So I'm going to go Q. I now have a change in temperature again. 125 times 4.184, 4.184 times my change in temperature. I am ending at 45 degrees Celsius, and in this segment of this graph, I started at 0 degrees Celsius. So 45 times 4.184 times 125. So now that gets me 3 different Q values, because I go through 3 different segments of the graph. Now for a Q total, all I have to do is add them together. And that would be the amount of energy needed to go from negative 15 degrees Celsius to 45 degrees Celsius. So that is why I want to see this little phase change graph up here, so you know how many Q values you need to do. You need to calculate. Okay?